system of international units This is known to be as SI units. There are actually two kinds of SI units, which is base units and derived units. And then there are 7 kinds of base units. These are meter, for measuring the length, then comes second, for measuring the time, mole for amount of substance, and then electric current, that is ampere. Ampere is used to measure electric current. Then Kelvin for temperature, and do not confuse this with degree Celsius. The SI unit for temperature is Kelvin. Kilogram used to measure the mass. And candela used to measure luminous intensity. These are the base units. Now there are actually a lot of derived units. Some examples include joules for measuring the energy, joules for measuring energy, the unit for force is Newton, then the unit for potential difference is volts, sorry, this is just L, potential difference. Okay, now since they are all derived units, there are actually a lot of derived units. All derived units can be converted in terms of, can be expressed in terms of base units. Let's say for example the joules. How do you convert this into base units? Well, if we know the definition of what energy is, we can find in fact what joules is in terms of the base units. Energy is work done. So what is work done? Energy is work done. So if it is work done, then work done is force times distance moved to the direction of force. To the direction of force. Force is measured in Newton, and the distance moved to the direction of force, this is the length. So the length is measured in meter. So just lowercase m for the symbol of meter. So this is Newton meter. This is not in base units. The meter in base, but the Newton is not in base units. So how do you convert this? As we know, 1 Newton is equal to 1 kg meter per second squared. So we can substitute the value for 1 Newton, which is kg meter per second squared times m. This is kg meter squared per second squared. So this is the base unit for joules. Well, this is much easier to write, but joules is a derived unit. Now let's convert volts into base units, as we have already converted Newton into base units in this calculation. So I think you got how to convert Newton, and it's very simple. So let's convert now the volts. Okay, now I'll convert volts into SI units. So from the definition of voltage, we know that voltage is the energy transferred per coulomb of charge. That means voltage is energy transferred per coulomb of charge. Per coulomb of charge. So this can be written as E over Q, where Q represents the coulomb and E represents the energy, and V represents the voltage. Since we already know what's the SI units for energy in base units, we have found in the earlier calculation, that is kg meter squared per second squared, that is for joules actually, and Q. Now how do you convert this Q? That's a question. So this coulomb of charge, how do you convert this into base units? So from the definition of current, which is current is from the definition of current, the rate of flow of charge. If this is current, then Q over T, and current can be represented by I. So now for Q, we know current is measured in ampere and time is measured in seconds. So Q can be written as, coulomb can be written as ampere seconds in SI base units. So kg meter squared per second squared divided by ampere second. This can be written as kg meter squared per second cubed per ampere. In fact, this is the SI base units for volts. If you want to find the base units for derived units, you need to know the definition. You can rearrange the equation and put just the units to help you find the base units. So keep practicing.